Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 7, Section 4, titled Applications of Linear Systems. By the end of this video, you will have reviewed methods for writing systems of linear equations. You will get to look at a couple of real-world problems, and you'll review methods of finding the break-even point. Please subscribe to this channel if you find it helpful. It would certainly help me a lot and the channel's distribution out into the world. Thank you. Objective 1, Slide A, Writing Systems of Linear Equations. Below is a summary of methods you have used to solve systems of equations. You must choose a method before you can solve a word problem. So let's look at the summary. Methods for solving systems of linear equations. Graphing. Use graphing for solving systems that are easily graphed. If the points of intersection do not have integers for coordinates, find the exact solution by using one of the methods below or by using a graphing calculator. Substitution. Use substitution for solving systems when one variable has a coefficient of 1 or -1. Elimination. You can use elimination for solving any system. Okay, example 1, it's a real-world problem. A metal worker has some ingots of metal alloy that are 20% copper and others that are 60% copper. How many kilograms of each type of ingot should the metal worker combine to create 80 kilograms of 52% copper? Let's see how we do this. First, let's create some variables. Let's let G, right here, G equal the mass of the 20% alloy, and let H equal the mass of the 60% alloy. Because we have 60%, an ingot of some unknown mass that is 60%, and the other is 20%, right? Here's our other one, 60 and 20. And so H is the mass of the 60. So those are those two, we've defined them. Now let's relate mass of the alloys and mass of the coppers. So for mass of the alloy, we can relate that to saying the mass of G plus the mass of H is going to be equal to 80 when we're all done. So we know we're going to have some mass of each. So the mass of G and the mass of H. And then for the copper, the mass of the copper, the amount of copper in each mass, okay, in each ingot times the mass, okay? 0.2%, not 2%, 0.2 or 20% of G, the 0.2 is the amount of copper, and 0.6 is the amount of copper for the other ingot, the H ingot, right? So we have 0.2 G plus 0.6 H. And that, when we add those together, it's going to end up being 0.52, right here, of 80. That's what we're trying to get to, 52 of 80 kilograms. So we want to end up with exactly 80 kilograms, and we want to know how much of each of those we have to mix together to get the 0.52. So solve using substitution. So first, choose one of the equations to solve for a variable. Well, we're going to choose the easy one. The easy one is right here. It's G plus H equals 80. That's going to be easy because then we're going to subtract, we're going to solve for G and subtract H from both sides. So we're going to get G is equal to 80 minus H. Now we know what G is in relation so that we can, once we find H, we'll know what G is in the end, right? So now step 2, let's find H. Using the other equation, 0.2G plus 0.6H equals 0.52 times 80. So now we're going to substitute the G right here. Substitute the G for what we found it to be down here, which is 80 minus H. So in fact, 80 minus H right there. Okay, so 0.2 times 80 minus H plus 0.6 times H is equal to 0.52 times 80. So then we multiply out 0.2 times 80 and we get 16, and 0.2 times H you get negative 0.2H plus 0.6H equals 0.52 times 80. So now we have 16 plus, because we had 0.6 minus 0.2 is plus 0.4 right here. 16 plus 0.4 is equal to 41.6. 80 times 0.52 is 41.6. So now we have a 0.4h equals 25.6 because we're going to subtract 16 from each side. Okay, 41.6 minus 16 is 25.6. So we can divide both sides by 0.4. H is going to be equal to 64. Dividing by 0.4 increases the value of the number, right? Okay. So now that we have that, we can go to step 3. Find G. We have H. H is 64. So now we're going to say G is equal to 80 minus 64. And when we do that, we're going to get G is equal to H. We've now solved it. We can now know to make 80 kilograms of 52% copper, 80 kilograms of 52% copper alloy, you need 16 grams, 16 right here, of the G, and the G was 20%. And you need 64 kilograms of the 80, okay, of 80. And 64 kilograms is of the 60% alloy. Okay, that'll solve that problem for you. Okay, example 1, check your understanding. It says directions. Suppose you combine ingots of 25% copper alloy and 50% copper alloy, and you want to create 40 kilograms of 45% copper alloy. Okay, how many kilograms of each do you need? It's basically the same problem we just did. So to begin with, well, first of all, we're going to let you pause the video and go do this on your own. And then when you come back, we'll do it together. Okay, so let's create some variables first. So let's create a variable. Let's say A is equal to the mass of the 25% alloy. Okay, and we're going to let B equal the mass of the 50% alloy. Okay, so now we got that much. And we know that we want 40 kilograms when we're all done. So we know that we're going to say A plus B is equal to 40. Okay, so that's basically what we have right there. And then another equation is going to be what? A plus B is equal to what? A is going to be equal to 0.25 times A plus 0.5 times B, and that's going to be equal to 0.45 times times 40 kilograms. So now these two are equated because we're both using 40 in both cases, okay? So now what are we going to do? We're going to rewrite. We're going to take a step where we're going to solve for one of these variables here. Let's solve for A. So I'm going to say A plus B is equal to 40. So therefore, A is equal to 40 minus B. You with me? Okay. So now we're going to substitute 40 minus B for A in the next equation. So I'm going to say 0.25 times 40 minus B plus 0.5 B is equal to 0.45 times 40. Okay, so now we'll take care of the distributive property right here. We'll take care of this piece here. 0.25 times 40, it's a quarter of 40 is 10, minus 0.25 B plus 0.5 B equals 0.45 times 40. So now we can combine these two right here. We can get 10 minus and plus. So it's 0.5 minus 0.25 is equal to plus 0.25 B. And that is equal to 0.45 times 40. Are you with me? Okay. So now we're going to move the first let's go ahead and calculate what 45 what 0.45 times 40 um, equals, okay? So I'm going to say 10 plus 2.5b is equal to 18, because 18 is 0.45% or 45% of 40. So now we have that. So now we can subtract the 10 from both sides. We're going to get 0.25b is equal to 18 minus 10, which is 8. Now, to find b is going to be equal to 8 divided by 0.25 is the same as multiplying by a 4, which is 32. So b is 32. If b is 32, go back up to our equation up here. We can just do it right here. A plus B is equal to 40. And we know that B is 32. A plus 32 is equal to 40. A must be equal to 40 minus 32, which is 8. So the solution here is we need 32 kilograms of B, and B is the 50% alloy. And we need 8 kilograms, 8 kg, 32 kg. We need 8 kilograms or of the A, and the A is the 25% alloy ingot. Okay, good job. Okay, objective 1B, writing systems of linear equations. This is the objective 1, slide B. When starting a business, people want to know what their break-even point is. And that the break-even point is the point at which their income equals their expenses. That's where it's zero. If it costs me $1 to make something and I sell it for $1, I broke even. If I sold it for $2, oh, I made money. I made $1, right? Because you subtract the expenses from the income. If I sold it for 50 cents, I lost 50 cents because it cost me $1 to make it and I only sold it for 50 cents. I'm down 50 cents. Break even is when the expenses and the income are equal to each other. Okay, the graph at the right shows the break-even point for a business. So let's see, we have wherever in the graph, and it goes like right down the middle here, we can see that anything down here, right through here, okay, is from on this side is losing money. On this side is gaining money. Why? Because on this side of this line, on this side of the point right here, on the right-hand side, the blue line is above the red line, and the red line is expenses. The blue line is the income. So you see the income is above the expenses. Anything below the break-even point, the red line is above the blue line. So the red line is the expenses. So the expenses are higher than the income. You get it? The break-even point is right where they switch. So you have the number of items sold and the dollars you make. That's what the graph is for. So you see it over here. Lose money on the blue side, make money on the yellow side. Notice that the values of Y on the red line represent dollars spent on expenses, and the values of Y on the blue line represent dollars received as income. So Y is used to represent both expenses and income. It's a dual graph here. Okay, example 2, finding a break-even point. Okay, let's see if we can do that. Suppose a model airplane club publishes a newsletter. The expenses are 90 cents for the printing and mailing of each copy, plus $600 total for research and writing. Okay, so the price of the newsletter is $1.50 per copy. They're going to sell them for $1.50 a copy. How many copies of the newsletter must the club sell to break even? That was that break-even point, right? Where the amount of money coming in is equal to the money spent to create that money that's going to come in. So let's define some variables. Let's start with defining X as the number of copies of the newsletter that we're going to sell, and Y is the amount of dollars of expenses and income. So we're going to relate Y to the expenses and going to relate Y to the income because the two of them combined create the final amount of money you're going to have. Your expenses and your income will be the final determining factor of how much Y or how much money you have, dollars. So let's relate expenses and printing costs plus research and writing. We're going to relate these two, okay? And to do that, we're going to say Y, there's that money again. The money in expenses is going to be 0.9 or 90 cents per copy plus the initial $600. And then for income, it's the $1.50 times the number of copies sold. And the number of copies sold is right here, X. So it's $1.50 right there, X. Y is $1.50 per X for the income piece of Y. So now choose a method to solve the system. Use substitution, since it is easy to substitute for y with these equations. Y, you already got y is what x says right here, right? So we can just substitute immediately 1.5x. So we're going to go down, we say, using the other equation, we're going to say y is equal to 0.9x plus 600 right here. Then we're going to substitute $1.50x for y. 150 is equal to y, so we're going to put 1.50x, okay, is equal to 0.9x plus 600. Okay, so now we're going to combine. What are we going to combine? We're going to subtract 0.9 from both sides to get the x on the left-hand side. And when we do that, you're going to get 0.6x. 15 minus 9 is 6, 0.6. And that equals 100. Excuse me, 600. And therefore, x is equal to 1,000. 600 divided by 0.6 is 1,000. So now we know what the x value is. Okay, so now you can go back and you can plug in, and you can see that to break even, the Model Airplane Club must sell 1,000 copies of the newsletter. And when they do that, this equation says that they'll be at that break-even point, right? They're going to be at that point right there. That'll be 1,000 where they're breaking even. Okay. Okay, example 2, check your understanding. Suppose an antique car club publishes a newsletter. The expenses are 35 cents for printing and mailing, $0.35 for printing and mailing each copy, plus $770 total for researching and writing. It's just kind of like the last one, right? So the price of the newsletter is 55 cents or $0.55 per copy. How many copies of the newsletter must the club sell to break even? Okay, so let's give it a try. Oh no, in fact, this is a check your understanding. I'll wait for you. Go ahead, pause, and when you come back, then we'll give it a try together. Okay, I'm assuming you paused and you've worked the problem yourself. It's just like the previous problem. You should have been able to do it just by going back and copying, okay? So let's figure it out. First thing we're going to do is we're going to create some variables. So I'm going to say, let's let x, x equal the copy sold. And let y is, I forgot the equal sign there, equal the total expenses. Okay, so now we have that. And we know what? We know that y, as the total expenses, is going to be equal to 0.35 times the number of copies sold, right, times x, plus $770, right? And when we solve for y, we can say that y is equal to how much money are they going to get? Okay, it's going to get 0.55x. So now we have the expenses part of y is 0.35x plus 770, and x is the number of copies they sell. And the income part of the y is the other part of the y, because it's expenses and income, is 0.55 times the number of copies. Okay, so now we already know that y is equal to 0.55x, so we can go to the top equation, and we can say what? We can say 0.55x, that's the y, is equal to 0.35x plus 770. And now we get to get the x alone on the left-hand side. So we're going to subtract 0.35x from both sides. And we do that, we're going to get 0.2x is equal to 770. Okay, now all that's left to do is solve for x. And x is equal to 770 divided by 0.2. And that equals what? X will equal 38. Oh, I wrote it backwards. Sorry. 38, 38.50. They need to sell 3,850 newsletters to break even. Okay? At 0.55 cents per copy. Okay, objective 1, again, slide C, writing systems of linear equations. In chapter 6, you modeled rate, time, distance problems using one variable. You can also model rate times distance type problems using two variables. Now, let's look at this problem. A steady west to east wind crosses the United States, acts as a tailwind for planes traveling from west to east. So if you're flying from California to New York, the wind is blowing at your rear end, pushing you faster. They call that a tailwind. Okay? The tailwinds increase the plane's ground speed. Okay? For planes traveling from east to west, the headwinds, they call it now, because now the wind is blowing at the front of the plane, the head of the plane, decrease the plane's ground speed. So you can see that in the picture. They're flying here from, let's pick a darker color. They're flying here. They're showing the wind from west to east. So from west to east, the airspeed plus the wind speed is equal to the ground speed. So you're going at, say, 500 miles an hour, and you have a 100-mile-an-hour wind, you're going to be going 600, because it would be 500 plus 100 will equal 600. You'd be going 600 miles an hour. If you're going the other way and you're going 500, let's see, you're going, it's airspeed, oh, I'm going in the wrong spot. So now I'm going this way, okay, and I have the headwind, so it's plus, let's see, 500 again, and this time it's negative 100. So the ground speed is going to be 400, because this is slowing you down. Even though you're spending gas and running the engines like you should be going 500 miles an hour, you're only really going 400 miles an hour on the ground across the country. Okay, so let's go ahead and look at one of these problems. Suppose you travel from Miami to San Francisco. It takes 6.5 hours to fly 2,600 miles against a headwind. At the same time, that's against the headwind. You're flying to San Francisco, so you're flying 2,600 miles into the wind, and it takes 6.5 hours to fly that distance. At the same time, a friend of yours flies from San Francisco to Miami. Her plane travels at the same average speed, which is some value we don't know at this point, and her flight is only 5.2 hours, so it's almost an hour and a half faster, right? Find the average airspeed of the planes and find the average wind speed. So let's see what we're going to do. First, let's let A equal the airspeed. Airspeed right here. Let's get a different there you go. A is equal to the airspeed, and W is equal to the wind speed. A for air, W for wind. Make it easy to memorize. Okay, let's relate this. With a tailwind, rate times time equals distance. So we have A, which is the airspeed, plus the wind speed, times the time is the distance. Okay, and we're going to write A plus W, that quantity, times 5.2, because that's how long it took to fly from west to east. And it's still traveling 2,600 miles. So with a headwind, the rate times time is distance. A minus the wind. So the airspeed minus, right here, minus the wind speed, because the wind speed's slowing you down now. It's pushing you backwards. Times the time you're traveling will give you the distance. Well, we know the distance. We know the times. We're trying to find the A and the W here, right? So in this case, the airspeed minus the wind speed times 6.5 hours is going to be equal to 2,600 miles. So what's step one here? Now that we have these defined, step one, divide to get the variable of each equation with 1 or -1 coefficients. So what that really is telling us to do is you have this right here, we have this distributive property feature, right? A plus W times 5.2. And the other one is A minus W times 6.5. Well, that's going to be, we're going to divide the both sides on the top equation by 5.2 and both sides on the bottom equation by 6.5. And when you do that, you're going to have just the 1a plus 1w. That's why they're saying get the positive or negative coefficient, or 1a or -1w. Okay, and that's equal to 500, which is 2,600 divided by 5.2, or 400, which is 2,600 divided by 6.5, right? So we get 400. So now we have these equations. And with that, we can now solve for what? Our W is, we have a plus and a negative, a minus and a plus W. So we can add these two equations. These two equations can now be added, and the W's will disappear. So we're going to have A plus A. So A plus W is 500, A minus W is 400. So we're going to have 2A, 0 W's, and 900. 500 plus 400 is 900. So now we have that. We can now solve for W. A plus W is 500. We picked that equation right here. And we're going to substitute the 450 because 900 divided by 2. So A is equal to 900 divided by 2 is 450. That's our A value. Well, actually, we actually skipped a step, didn't we? Solve for A. So 2A is equal to 900, A is equal to 450. So that's where the 450 came from. Sorry for skipping the step. So now we have A plus W is 500. So we can put the 450 in the A value location. Okay. Plus W equals 500. So W, we're going to subtract 450 from 500. W is equal to 50. The average speed of the airplane, the A part, is 450 miles per hour. And we have that right here. For A is equal to 450 miles per hour. Okay. And the average wind speed, the W, is 50 right here, 50. So that's the wind pushing or helping or hurting. Okay. And so that's 50. So W, the wind speed, is 50 miles per hour. Okay? Good. Okay, example 3, check your understanding. Your plane takes about 6 hours to fly 2,400 miles from New York to Seattle, Washington. At the same time, your friend flies from Seattle to New York. His plane travels with the same average speed, but his flight is 5 hours shorter. Not 5 hours shorter, 5 hours, an hour shorter. Find the average airspeed of the planes and find the average wind speed. Go ahead and pause the video, please. Try this, and then when you come back, we'll do it together. Okay, I'm glad you made it back. So let's go ahead and give it a try. So the first thing we're going to do is we're going to let A equal to airspeed. So let A, capital A, equal airspeed. Okay, and we're going to let W equal wind speed. Okay, and then we have two formulas to write here. We can say going from Seattle, let's see, A plus W. Let's see, A plus W. That's the airspeed, and adding the wind speed is going to be equal times that times some time is equal to distance, and a minus w times time is also equal to distance. Now the a minus w here is you're flying your plane and then your plane is slowing down because the wind is pushing at you. That's flying from what is it, New York to Seattle. The other one, a plus, is when you're going from Seattle to New York, because now you're going west to east. Or I could write it that way. This is west to east, and this one is east to west. Okay, that's what's going on here. When you're going east to west, the wind is hurting you. It's subtracting from your speed. Okay, so now that we have those two, let's put the numbers in. So we have a plus w, or a, let's go with a minus w. A minus w times time, and the time is going to be 6 hours because we're going from New York to Seattle, and that's going to be equal to 2,400 miles. And then the other equation is going to be a plus w, oops, sorry, a plus w times 5 is equal to 2,400. So now we have both of these equations are equal to the same thing. They're equal to the same distance. So we can set them equal to each other, right? That's what we're doing. So now that we have that, before we move on, we're going to try to get these coefficients of the a and w terms to be 1 or negative 1. Okay, so in the first one, that's going to be positive 1 for a and a negative 1 for w. And then the second equation here is going to be a positive 1 for a and a positive 1 for w. In order to do that, we're going to divide each side by the coefficient of this a plus w or a minus w term. So when you do that, I'm going to carry it over here. I'm going to say that that equals a, what do we have, minus w is equal to 2,400 divided by 6. And that's going to be equal to 400. Right? And the other one is going to be a plus w, and that's is going to be equal to 2,400 divided by 5. And what is that? That's going to be equal to 480. 480. So now we have that, right? We have that equation. So now that we have these numbers, we can say now that a minus w, it doesn't matter which one we pick, is 400. And a plus, we can rewrite this equation. So we can say a minus w is equal to 400, and a plus w is equal to 480. And we can add these, because these are minus and plus, or plus, positive and negative. So we're going to get 2a plus 0w is equal to 880. Oop, I wrote 480. 880. Okay? And if we divide a by 2, we're going to get 440. Okay? A is equal to 440. So now we have a equal to 440, and we can substitute that in, that we can pick any equation we want. We can say, let me see which one I'm going to pick. Okay, I'll pick this equation, and that I'm going to rewrite it so it's a little cleaner. It's going to be a plus w is equal to 480. Okay, so now I'm going to substitute 440, which is our a value right here. A is equal to 440. I'm going to substitute here. I'm going to say 440 plus w is equal to 480. And when you do that, you're going to solve for w. You're going to subtract 440 from each side. You're going to get w is equal to 480 minus 440. And w is going to be equal to 40 miles per hour. And the plane traveling is going to be, the a is equal to 440 miles per hour. Okay, good. I think you did good on that. I'm sure you all did well.